Hi.
You can start. Okay.
My presentation correlation coefficient for interval valued Fermatean Hessian fuzzy set with pattern recognition application and other making decision method. 6 section. One section will be introduction, literature will be given. Preliminaries section, I give you definition and theorem. Correlation coefficient is my procedure method and application, advantage of the new approach, and conclusion. An interval valued Fermatean Hessian fuzzy set is a combination of the interval valued Fermatean fuzzy set with Fermatean fuzzy Hessian fuzzy elements in the form of interval values. Therefore, interval valued Fermatean Hessian fuzzy set are existence of Fermatean Hessian fuzzy set, which are powerful tools to represent more complicated, uncertain, and vague information. This strategy aims to focus on all kinds of correlation coefficient for Fermatean Hessian fuzzy set and extended them of correlation coefficient and weight correlation coefficient for interval valued Fermatean Hessian fuzzy set. At least the numerical examples show the feasibility and the applicability of the proposed method in the multiple criteria decision. The Fermatean fuzzy set was initiated by Fermatean. In the Fermatean fuzzy set, the membership degree and non-membership degree accomplish property. The FFS, which is included in the literature as a new concept, gives better result than the intuitionistic and Pythagorean fuzzy set indefinite uncertainties. In SNRPT, some properties score accuracy function FFS are solved. Future, the TOPSIS method, which is the frequency used multi-criteria decision program, has been applied to FSS. In addition to SNRPT, the TOPSIS technique, which is continuity unitized in making decision multi-criteria making decision program has been updated. As a continuation of this work, Fermatean investigated several new operations, subtraction, derivation, Fermatean arithmetic mean operators over FFS, and employed Fermatean fuzzy weighted protected model to solve a multi-criteria making decision making program. In this study, aggregation operator belonging to the FFSN have been defined and the properties related to these operators have been examined. In study, Tanghai, the notation of Fermatean fuzzy linguistic time set is offered. Operation score and accuracy function belonging to this set were given. A new similarity measure related to Fermatean fuzzy linguistic time set is constructed. The new measurement is a combination of Euclidean distance measure and Cousin similarity measure. Akirish defined Fermatean fuzzy soft set and give the measure anthropology based on Fermatean fuzzy soft set. In Kirch's paper, a new Hessian fuzzy set, which is called the Fermatean Hessian fuzzy set, has been given and investigated some properties. In other paper by Kirch, the Electra method is defined by Fermatean fuzzy set according to the group decision-making process in which more than individual interact at the same time. Shahghazi paper, a decision support algorithm in accordance with the Fermatean fuzzy soft set concept presented to the maximization effectiveness of antivirus mask. In another paper, various Fermatean fuzzy reference relations have been defined. An additive consistency based on a probability vector has been given. In addition, a model is presented to obtain a missing decision in complete Fermatean fuzzy set profession relations. In the study, there are different applications such as aggregation operators and information measures to solve a decision-making problem. Except that this solution method, another method for the choosing the best alternative is correlation coefficient, which are used to measure the level of dependency between two sets. SSC are used to measure how strong a relationship is between two variables. SSC is a bivariate statistic when it summarizes the relationship between two variables, and it is multivariate statistic when you have more than two variables. Therefore, there is a very wide field of study, from science to economics, from engineering to medicine. Although existing probabilistic methods have successful results, they also have limitations. For example, probabilistic techniques are in the accordance with a mass collection of data, which is random to acquire the necessary confidence level. However, on a great scale, the complex system has massive fuzzy ambiguity, owing to which it is to acquire the complete possibility of the events. Hence, outcomes according to probability theory don't all the time ensure beneficial information to be professional, owing to the limitation of being able to operate only quantitative information. Furthermore, occasionally there is inadequate data to accurately operate the statistic of parameters in real-world practice. As a natural consequence of this limitation, the outcomes in accordance with probability theory do not all the time ensure beneficial information to the professional, and then the probabilistic examination approximation is insufficient to account for such built-in uncertainties in data. There are many possibilities to overcome this difficulty. One of the most successful results of these possibilities for handling uncertainties and the impreciseness in the decision-making is method based on fuzzy set theory. In Chang studied correlation of fuzzy information according to classical statistics, solved and ensured a formula for SSC of fuzzy sets. In Liu paper, the assess of fuzzy information by utilization of the mathematical programming approximation according to the standard definition has been investigated. Based on the result were obtained through FS theory. More comprehensive and more accurate results were obtained with institutionalistic fuzzy set. The theory of IFS considers non-membership degree together with the membership degree and requires that their sum be 1 or less than 1. The CC derived based on IFC have been operated in numerous different fields as cluster analysis, image processing, pattern recognitions, etc. Many DM problems related to Pythagorean fuzzy set information have entered the literature thanks to PPFS, which has introduced to overcome the limitation IFS. SSC derived according to IFS, where PFS theories are available in the literature. It is the aim of this study to give a coefficient, correlation coefficient and a weighted correlation coefficient formulation to measure the relation between two IFHFS. The effectiveness of the proposed techniques will be demonstrated by giving the numerical example of the pattern recognition and multi-criteria decision making. Definition: institutionalistic fuzzy set is defined like this. Zeta is said to be membership degree, eta is said to be non-membership degree. Pythagorean fuzzy set is described like this, and Fermatean fuzzy set is described like this. The hesitant fuzzy set is described like this. And the Fermatean hesitant fuzzy set is described like this, and the conditional is three conditional days. Information energy of Fermatean fuzzy set N is described like this. And theta indeterminacy degree is calculated like this. And N and M is Fermatean fuzzy set, then correlation is calculated like this, and correlation coefficient calculated two method. One like this method is classical correlation coefficient, for example, and the other correlation coefficient like this. In this define information energy is maximum. Then the last definition, interval value Fermatean hesitant set is defined like this. And this interval valued set, we define the informational energy of Fermatean fuzzy set like this. Then we correlate, evaluate like this, and interval valued fuzzy Fermatean set F and G if choose correlation coefficient. This is described like this. And this Fermatean fuzzy set, there are three conditions even like this. Example, if F and G, their value is this, informational energy F 1.9, information energy G 2.74. Then correlation calculate like this, 1.81. Then the correlation coefficient is 0.734. The maximum information energy correlation like this, and the conditions F and G like this. Take a weight vector, yani weighted correlation coefficient is defined equation for satisfied like this condition. Then maximization function'da CC between, weighted CC between this condition satisfied. Pattern recognition application example, if we choose the PR1, PR2, PR3 and finite universe like this. And another unknown pattern UP like this, then we determine the correlation method, and we computed from UPR to PR are the given the follows. Then we show that PR3 UP the same set because the correlation coefficient is then upper the others.
Sorry for interruption, Professor. You have left 2 minutes.
Okay, thanks. Then another example, multivariate criteria methods like this. A scientific committee should evaluate a four possible project LI according to 3 criteria KI. Here, C1, C2, and both benefit criteria, and C3 is the cost accreditation. Take the weighted factor of criteria like this. This decision matters is given by the expert as a table like this. Then the correlation coefficient is calculated. Then we evaluated these solutions. Then F3 is the upper value like this. Okay, then conclusion in this study, a correlation coefficient for interval value Fermatean hesitant fuzzy set has been proposed. The shortcoming of the existing operations have also been highlighted in this study. Based on that, the presented paper have extended the theory of the correlation coefficient from Pythagorean fuzzy set and to Fermatean fuzzy set, in which is the constrained condition of the sum of membership and membership degree. Then one has been relaxed. Numerical example have been given that demonstrated that the proposed correlation coefficient can easily handle the solution, where the existing correlation coefficient in Pythagorean fuzzy set environmental fields, the proposed correlation coefficient Fermatean fuzzy set has been developed by taking the degree of membership, non-membership, and the degree of the hesitant between them. Thank you.